So we're going to have a look at simultaneous equations, and there's 3 different methods that we can use to help us to solve them. The first one is the elimination method, the second one is the substitution, and then the third one we're going to look at is the graphing. So there's the 3 different methods, and depending on how the question is given to us might change how we prefer to answer it. They will all give you the correct answer. Sometimes you'll be asked to do it a certain method, but if not, then you can choose what's most appropriate. So for the elimination method, this works particularly well when the x's are stacked together, the y's are stacked together, and the numbers are stacked together. If it's not given to you like this, then you could rearrange it to write it like this, and the elimination method would still work. So the reason that we call it the elimination is because I can subtract or add the equations to eliminate or get rid of one of the letters. So for example, I might want to subtract these 2 equations, because if I subtract them, I have 2x minus x, and that gives me 1x. And then I have y minus y, so that gives me 0. And then 14 minus 8, which gives me 6. So overall, x is equal to 6. So I've already managed to find one of my variables. So this is why we call it elimination, because I've got rid of my y value. So once we've found that x is equal to 6, we can then find the value of y by using one of the equations. So you can use either of them, it doesn't matter. I'm going to use this one just because it's slightly easier. It's just 1x and 1y, so it will keep my numbers lower. So I now know that x is 6. So instead of x plus y equals 8, I'm going to put 6 plus y is equal to 8, because I know that x is 6. Then I can solve that equation, so I can subtract 6 from both sides, and therefore I find that y is equal to 2. And now I have my final answer, where x is 6 and y is equal to 2. So that's the elimination process. Again, this one's another elimination. So we've got the x's in a line, the y's in a line, and the numbers in a line. So that's what helps us to see that elimination might be useful. So on this one, I'm circling the 2 variables that are the same. So the coefficients are the same, they're both 4. However, one's plus 4 and one's minus 4, so the signs for them are different. Therefore, I need to add them. If I subtracted them, I'd end up with 8y, and I want to get 0, I want to eliminate them, so I need to add the 2 equations together. If the signs are the same, then I can subtract. So I can do 3x plus x, that gives me 4x, and then 4y minus 4y, because it's plus minus, that gives me 0, and then 30 plus minus 22 is going to give me 8. So 4x is equal to 8, therefore x is equal to 2. I'm dividing by 4. Again, then I can take one of my equations, so I'm going to take the bottom one, substitute in the one that I've found, and write out the whole equation again. And then I can rearrange it to find y. So I'm going to actually add 4y to both sides, just so that y is keeping positive. So 2 is equal to minus 22 plus 4y. Then I can add the 22. So now I know that 24 is equal to 4y, in which case if I divide by 4, y is 6. So my final answer is that x is 2 and y is equal to 6. These questions are also going to lend themselves to elimination, since the variables are all stacked together. However, there isn't a coefficient the same for both of them. So 3x and 2x, I can't just subtract those or add them, and I've got 1y and 2y. So instead, sometimes we need to manipulate one of the equations, and in this case, I'm going to multiply the top equation by 2. And if I do that, I would end up with a 6x here, and I would end up with 2y, and I would end up with 22 at the end. And now that I've got that, the variables are the same, so now I can subtract them. So sometimes when you're doing elimination method, you might need to multiply one of the equations, or in this case, multiplying one of them won't really help. So you might need to actually multiply both equations. So on this one, perhaps we need to multiply the first one by 2, the second one by 3, or we could do it the other way around. It depends if you want to match the x's or the y's, and then you would be able to eliminate one of the variables. So that would give you 6x plus 4y is equal to 28. And then on this side, it would give you 6x plus 9y is equal to 33. We've now managed to get the 6x's the same, so now we know that they're definitely going to work. So just be aware of that when you're doing the elimination method. The second method we spoke about was the substitution. So if you're doing substitution, then it helps if you've got one of them already solved, so like y equals, and then an equation linking the two together. Because we can put this part here, which we know is y, substitute it straight into y in the other equation. So if I rewrite this one, I have 5x minus 2y, but we know that y is just 5 minus 2x. So instead of putting y, I'm going to put 5 minus 2x. And that is equal to 8. So I've written out this equation, but I've put y in as y. So that then gives me, if I multiply out my brackets, I end up with minus 10 plus 4x. So I've multiplied out the brackets, and then I've still got the 5x and the 8 there. So I've got in total 9x minus 10 is equal to 8. And if I add 10 to both sides, 9x is equal to 18, and therefore x is equal to 2. And what's nice about this is if I look at that first equation, it's already perfectly done for me to put in x and find y. So I'm going to take that first equation, y is equal to 5 minus 2x, but we just found that x was equal to 2. So 2 lots of x, and that then gives me 5 minus 4, so y is equal to 1. So I'm able to use my answer to help me to find y. So y is equal to 1 and x is equal to 2. So that is your substitution method. You don't have to have them presented in this way. You can also just rearrange them so that you've got x or y solved, and then you can substitute that into the other one. So you could actually still use that with a question that's presented in this way as well. It's just that you would have to rearrange it first. So another type of substitution is if they're both arranged in that way, y equals 3x plus 2 and y equals 4x minus 4. And in this instance, if they're both equal to y, then both of those things are equal to each other. So 3x plus 2 is equal to 4x minus 4. You can either think of it as taking this value and putting it into y, or if they're both equal to the same thing, then y and y are equal, and so are 3x plus 2 and 4x minus 4. And now we can do what we did previously. So we're just going to rearrange that equation and find x. We've managed to get rid of y, so we're just finding it for the one variable. So we can subtract 3x from both sides. That gives me 2 is equal to x minus 4. Then we can add on 4, and that gives me x is equal to 6. And then again, they're already nicely rearranged for me, so I can take either of these. 4 lots of x minus 4, so y is equal to 24 minus 4. and then 20. So I now know that y is 20 and x is 6. So that's your substitution method. The third method is the graphing method. This is probably the less likely method that you're going to jump to. However, if you've got graph paper, then you can use this. You can also check it with a GDC. If you look at the TI Inspire video, then that will help you with how to do this on a TI Inspire. So we're going to draw the axis, and we're now going to need to draw both of these lines on the axis. Now it works particularly well when they're arranged in this format, because they're arranged in the form of y equals mx plus b, and we know that we can draw those more easily. It's already there with the gradient m and the y-intersect b. So the first one has a gradient of 3 and it goes through 2. So you would then need to obviously draw this more accurately on squared paper. You'd have a gradient of 3, so for every 1 square across, you're going up 3. 1 square across, you're going up 3. Then you've got your second one, which is a y-intercept of -4. And this one has a gradient of 4. So it's a steeper gradient on this one. So something like this. So this one, every 1 across, you would go up 4. Every 1 across, you'd go up 4. And at some point, these lines will then cross. So you're going to find the coordinates of this intersection. So this coordinate would give you x and y. And that is the solution to your simultaneous equation. So when x is such and when y is such and such. So you can either use your calculator or squared paper and graphing to be able to solve the equation graphically. Again, it will work for other types of equations. It's just nicest when we have it in this form because it's already in that y equals mx plus b format.